Welcome to Fluid Mechanics lecture series. In this video, I am going to discuss about one of the fluid property, surface tension. Let us start with a definition. Surface tension is a property of fluid which is at rest. Surface tension is an elastic tendency of fluid surface which make it acquire the least surface area. Think about a raindrop or a water droplet on lotus leaf. The lotus leaf has a waxy surface, so the water droplet cannot mix or spread on the leaf. It will acquire the least surface area and appears as a droplet. And think about a raindrop. The raindrop is always a spherical shape because the water droplet always occupies the least surface area, and that property is due to the surface tension. The another definition of surface tension is the property of fluid which makes it free surface to be stretched elastic membrane. See the swimming pool, the free surface of water molecules arrangement. At the top surface, all the molecules side by side and all are closely packed, and below the molecules you can observe all are random. From this, all the molecules which are sitting at the top will be strongly attached by the molecules which are below the surface of the liquid. It will appear like a stretched elastic membrane. Another example, if you take a needle and apply some oil on it and leave on the water surface, it will float on it because when the water surface will be in contact with a thin oil film, it will not mix up with the water due to surface tension. So, the needle will float due to surface tension difference between water and oil molecules. Let us see another example. Some type of insects can walk on the water. It is because of two reasons. One is due to surface tension, and another reason is they can spread the weight of them equally by their legs. The surface tension is due to the waxy fluid which is released by these insects from these legs. It cannot mix up with the water, so they can float and walk on the water. Now, let us see the mathematical and the technical approach of surface tension. It is represented by the symbol sigma and is actually measured in force per unit length. Let us consider first a water droplet. Now I will cut like this two halves. If I check on the surface on this cross section, the pressure force inside the water droplet is equal to the surface tensile force acting along the circumference of the circle. For equilibrium condition, the pressure force is equal to the surface tension. If you simplify this, finally you will get pressure is equal to 4 sigma by d. Now let I consider a water bubble. It is a hollow and has two surfaces. One surface in contact with inside air and another surface is contact with outside air. Bubble have two surface tensions. The pressure force multiplied by the area of cross section, and the surface tension is acting on the circumference, and one is acting outward and one is acting inside. Simplifying these terms, finally we got the pressure is equal to 8 sigma by d. Let us consider a water jet. Water jet is nothing but if you leave some water from a tap, the water jet will strike on the ground. If I take some part of it having the length L and diameter d, and I can say the surface tension is acting on the edges like this on the length. The pressure is acting on the rectangular portion. Finally, simplifying this, we get the pressure equal to 2 sigma by d. That's it, friends. Hope you are understanding this. Thank you.